Okay, so let's talk about AI bias and what it is, what it looks like, and why it's so problematic, and ways I think we have a hard time understanding. So already introduced me, so bypass this. So let's start by talking about what is artificial intelligence. And so that's the first thing is what is intelligence? So we would define intelligence as the capacity for logic, understanding, self-awareness, learning, emotional knowledge, reasoning, creativity, critical thinking, and problem solving. But more generally can be described as the ability to perceive or infer information, retain the information as knowledge, and apply it to an adaptive behavior within an environmental context. So we can take that definition of intelligence, and one way to understand artificial intelligence is just to apply it to a machine, right? So let's say a machine which can perceive or infer information to retain it as knowledge to apply to adaptive behavior within an environment. Oftentimes, AI, artificial intelligence, used to describe machines that mimic cognitive functions that humans associate with humans, such as mind or learning. I prefer to define AI in a very simple terminology, which is a machine that can reason, that can sense, reason, learn, and respond to its environment to achieve a goal. So that's sort of how I conceptualize artificial intelligence. So, if you go to a conference, and, I used to go to academic conferences before the pandemic, and you run into two types of professors. There are people who are over the age, I guess, over the age 60, and they'll tell you, AI, it's old news. We've been doing that for ages. There's nothing there, no big deal. No point of even paying attention to it very much. And then you got professors who are probably under 30, and they think artificial intelligence is now changing the world as we know it. And so what happens is that for a lot of people who've been around, AI is, they think of AI as what we call now good old fashioned AI, which is basically if then statements or rules or expert systems. And so in essence, what we did when we developed these expert systems is that back in the 70s and 80s, we actually sit down with experts and mapped out their thought process. Actually, and then we developed these rules. If it was this, if it was that, you go here, you go there. And those systems were well thought out, and they were pretty mimicky to the human behavior or the human decision-making process. And we understood those AI systems very, very well, right? That was the whole point. The problem with those systems, it takes a long time to develop those systems. And the world is just changing too fast, right? It's just changing. So now you would spend all the time with experts, and before you could actually develop the actual system, the world has changed and moved on. And so those rules are not as effective. What's driving the world now is what we call machine learning. And this is the scientific study of algorithms or statistical models that computer systems can use to perform a specific task without explicit instructions, right? That's the key thing, right? So with machine learning, you don't have to give it detailed instructions. It instead relies on patterns and makes its own inferences. And so machine learning is what's really driving this new revolution or wave of AI. It's not good old fashioned AI, which is what we've been doing for years. It's the fact that with machine learning, we can bypass. Now, there are pros and cons. We really understood the good old fashioned AI. It took longer, but we actually understood what the machine was doing, right? That was the whole point of why it took so long. With machine learning, it's a lot faster. Heck, it can work in real time, but we often don't understand what's it doing. So I'll go a little bit further here. So when we talk about AI, you can define AI on multiple levels, but one way to look at it is weak versus strong AI. So weak or narrow AI is AI that can address a very narrow set of tasks or problems. Example, virtual assistants and autonomous cars. That's what we define as weak or very narrow AI. Much of the AI that you have encountered or will encounter in the next 10, 15 years is easily going to be weak or narrow AI. Then you have strong or broad AI, and that's AI that can address a wide range of tasks and problems. So that's, you think about general intelligence, right? And examples of that are Google's AlphaGo, IBM Watson. Those are like really big. You think about highly powered systems, right? And there's maybe you know, I would say maybe a handful of AI systems would fall into that particular category. Most of them don't. And then, you know, forward looking, we have something that we call super intelligent AI, which doesn't really exist. So it's AI that possesses the intelligence that far surpasses the brightest and most gifted human minds. If you would think in terms of, if you ever watched the movie Terminator, Skynet would be a super intelligent AI. If you watch Captain Marvel, the Kree has this super intelligent system, right? This is super intelligent. It's basically something that doesn't exist yet, more scientific than anything. But you can think of an AI that has the not only has the general knowledge of a human, but surpasses the knowledge of a human in any aspect whatsoever. But for the most part, what we're talking about in our society today is weak or narrow AI. Although most of the horror stories or nightmare anticipations really focuses on super intelligent AI. And so they're not the same thing. We're not going to be taken over by AI if it's weak AI or narrow AI or even strong AI isn't going to take over the world, right? So we're a long way from the kind of systems that will cause us major catastrophe. So there's different types of machine learning. There's what we call supervised learning. And basically it's a machine learning approach that focuses on producing an input function that predicts an output by employing labeled training data. So here's an example of that. So I have some data I got from organization. It's labeled in the sense that every column has a name. There's age, there's gender, so forth. So, and then I develop a model. In this case, I would say, I want you to, I want to be able to take this data and predict somebody's performance. And we try that model, and then we try to take the same model and apply it to new data to see if it's accurate. This is what we call supervised learning, machine learning, supervised learning. Then we have something we call reinforcement learning. And it's a machine learning approach that focuses on allowing the agent to take actions and interact with the environment in an attempt to maximize some total reward. I actually use this a lot in my lab, and we use it in terms of agents, in terms of autonomous vehicles. So we will build this city, virtual city, have the autonomous vehicle navigate through the city, say, hey, get points when you don't, when you follow the rules. You lose points if you hit someone or you get into an accident, right? And so it goes through the city, it learns, it makes mistakes, then it takes what it learns and goes through the city again and tries to score more points. And it goes that thousands of times, right? And over the course there, you can develop an AI algorithm, in our case, control algorithm, that we can put into a real autonomous vehicle. And that controller will really, like, basically it has went through all these different tests and has, and the end result that algorithm can really help the autonomous vehicle, in theory, guide itself through a real city. So reinforcement learning. Then we have unsupervised learning. And this is an approach where we have data that's not labeled, and we are hoping that the machine learning algorithm is going to find something that we don't know is there, right? So in this case, we have data, we don't know what the data is. It's actually not labeled. We say, come up with some classification model. So you figure it out, right? And then it comes up with a model, and then we try the model on a new data, to see if it's still accurate. A good example of that is we do this to cluster data. So let's suppose we have a bunch of users and a bunch of data about our users, but we don't really know what it means or what it can tell us. And we will tell the system, we will essentially find ways to find which users are similar on certain data, and it could produce a cluster. And so if this was our users, it would tell us that we have 3 clusters of users, and then we would look and see, okay, what do they have in common, right? So they may tell us that one set of users come to our site for, to purchase equipment. The other one comes to look for information. The other one comes to look for services. And then we can better tailor our website to address a particular user when a user in one of those clusters actually log on. Another use for this kind of analysis is security, because what happens is if you can look at these dots that are not near an actual cluster, that means they're abnormal, which means in many cases there are a hacker. So in many cases, all these actual dots that are not within a cluster are anomalies, and in many cases they're security concern. So we can say, okay, we tend to get 3 types of users to our site. Someone way out here is, not really in any one of these clusters. So something is unusual going on with that user. All right. And so in many cases for security purposes, they use this a lot. So what's driving into artificial intelligence now, at least machine learning? We have the ability to capture and store large data sets. We didn't have that even 10, 15 years ago. All right. We had 10 or 15 years ago, if you have an organizational data and you wanted to store it, you actually stored it offsite at maybe a data warehouse. Right now, you can store it in real time. You can capture it and store it. We also have the computing power to go and process this data and do it in real time, right? In very dynamic situations, and that's important, right? Because now the world changes so fast. Things are moving so fast that we have to be able to take this data and make real time decisions and update that, an hour later when we get more information. Right? And its cost. This is a whole lot. All the data and the ability, the processing power is relatively cheap. It's got disproportionately cheap over the last 10 to 15 years. So almost anybody can do this, right? I mean, small businesses can purchase this equipment and use this approaches, right? So that's really driving the phenomenon now of artificial intelligence as via machine learning. Now we talk about bias AI. So, I don't know if you're familiar with this, but recently, maybe a year or so ago, Amazon had developed an AI recruiting tool. And if you're Amazon, for example, you get tons of resumes online. I mean, this is a big problem for any organization, but you get all these, hundreds of thousands of resumes in a given year. And you want a way to go through those resumes fast to pick out the people that you think are most qualified. And so they develop an app, an artificial intelligence app that will allow them to shift through all the resumes and then recommend who should be interviewed to the HR people. They use this app and they were really testing it, and it basically produced a list of all men, and it actually didn't produce any women. So it didn't recommend any women to be interviewed, and so they determined this was bias. Amazon scrapped it before they actually really deployed it. So that was they wanted to test it out. And there's other articles on bias AI, why it's so hard to fix. There's a lot of discussion about gender bias in the AI system. I think there was a bank that developed some credit line application where basically you could log onto the site, put in your information, and the AI could essentially determine what level of credit you would get in loan. They discovered that it was actually biased against women, that all things equal, it would only provide women with a much smaller credit line than men. And so I think it's actually a legal case that's ongoing. So, you've seen all these cases are popping up. I'm sure you hear a lot about AI bias. And even now people think that, this is a huge problem for our society going forward. Now, so I'm going to define AI bias for this presentation as a biased AI disproportionately weighs a criteria in a way that is perceived unjust, closed-minded, or presidential, right? So that's how I'm going to open definition of biased AI. But I want to take a step back because, it was thought that AI would remove the bias, right? We thought humans were the source of bias, and artificial intelligence were going to come in there and clean house and remove the bias, right? So, and even in 1993, we thought the advantage of AI was they could make consistent decisions, greater reliability in the decision process. Even recently, 2016, There's articles being published saying that we think AI can be much more impartial in its actions than human being. There was a recent article, 2019, in the Harvard Business Review, who proposed that AI could eliminate bias from the hiring process. So we actually thought and believed that the AI system would be the solution to actual bias. Right. So we didn't actually get here by thinking AI would be a problem. And there's some people who still see AI as a solution, not the problem. So let's think about how AI actually works by machine learning. There's some data. It develops a model from the data, or vice versa, some iterative process, depending upon what approach you take. But you have data, you have a model, and then there's some level of prediction. A lot of what AI does is prediction. And based upon that prediction, the AI has some level of autonomy. If it could recommend you a date, right? It can match you on who to pick you up. It could recommend a restaurant. It could recommend who to hire. If you give it more authority, it could make a decision on who to hire. In some cases, it can even take action and actually say hire someone, right? So there's some level of autonomy, but in most cases, the AI stops with some level of recommendation, right? It recommends on Facebook what article you should read. It recommends on who you should connect with on Facebook. But ultimately, it's data model. It tends to predict, some way of giving you a good interaction, whether it be you buying something you want to buy, recommending a restaurant that you want to eat at. But the idea is that it's going to try to take some data to predict and offer you something. So let me take a step back and bring in how I got start thinking about the issues of AI bias. Before COVID, I used to travel in academic conferences, and typically my travel would, I would fly into a major airport, and I would get an Uber from the airport to a major hotel. So, I mean, the hotel itself was always, a conference hotel. So it wasn't like it was on a particular side of town. It was typically a tourist area. It wasn't, in a neighborhood. And so I would land in there, and I would basically open up my app, and I would, call an Uber. And I noticed, I would get this, I would accept I would always accept whoever took it, And I noticed that I would seem that when I would travel across the country, I would, my driver was always either an African-American, because, I'm an African-American, or a person of color. And was always matching me with, I'm pretty much an African-American or someone of color. And I thought, what if it's actually trying to, what if that, it could be that most of the Uber drivers are African-Americans. It could be that my timing, is such, right? There could be a lot of things. And obviously Uber doesn't just match on demographics. But I started wondering, what if Uber was trying to match me with someone who was like me? And that could happen for one or two reasons, right? So it could be that basically Uber discovered through data that I tended to rate someone who was an African-American driver higher. I gave them a higher rating. Or it could be that a white passenger gave them a lower rating. So if you Uber and you have some algorithm and it's trying to maximize my experience or the experience of the passenger, if I was giving, African-Americans a high score, it may somewhere back there in the data somewhere, it may be all things being equal. It may pick the first person who's nearby, but if there's multiple choices, they could be working out in a way that I disproportionately get matched with someone of the same race. Now, this is not entirely crazy, because fact of the matter is Uber discovered that women on average much prefer to be picked up by other women when it comes to drivers. So I think about maybe a year or so ago, Uber engaged in a campaign to get more female Uber drivers, because they discovered that women, especially if they travel in a new city or if they're out late, they would prefer taking an Uber from a woman driver, not a male driver. So, so that does take place. Uber, will recognize that and try to match a woman with a woman driver if possible. So my suspicion is not completely unfounded. So a lot of this is what we call homophily, right? Homophily is the tendency for people to seek out or be attracted to those who are similar to themselves, or the tendency of individuals to associate and bond with similar others, as the proverb, birds of a feather flock together. The categories of which homophily occurs could be age, gender, class, organizational role. It could be a lot of different things, right? But what we know for the last 100 years, social science, is that homophily is real, right? People tend to cluster together. Like people tend to cluster together in many different ways throughout our society. For example, example, what drives homophily? So basically, according to the similarity attraction phenomenon, social science, people tend to be attracted to people like them. For people who are like me, and it could be anything, it could be race, could be gender, could be nationality, but people who I think are like me, I tend to think they're like me in a lot of different dimensions, unreasonably, right, unrealistically. And I tend to care for people who I see are like me or in my in group more. I tend to assume those people are good, because they're hardworking and honest. Why? Because it's self-fulfilling. So if I think you're like me, I'm going to attribute all these wonderful things to you. And people who I think are not like me, I'm going to see them as dim. They're all the same. I minimize the individual. And the worst case, I'll say they're all bad people. Unknowingly, I could have biases against them. So it's not the case where I'm going to outright be racist and say I'm going to give a person a low score. I may give them a little bit lower score than I would if they were someone of my same race or gender, for example. In some cases, yeah, some cases can be actual discrimination, right? Because one could just give someone a low score from that, right? But in many cases, these biases are very subtle. But when you have an AI system that records all these interactions, this can basically magnify. So some of these attractors, things that attract like people, it could be we call surface level attractors, gender, race, and age. If we're the same age, we could be attracted to each other. That's a form of homophily. Could be other things that are deeper, like our values, our beliefs, our attitudes. These two things don't have to be related, but they normally are, right? And so if you look at the election, not the last election, but the one before that, you'll see that if you told me someone's race, you could predict to what degree who they voted for. All right. So in many cases, and that's because homophily is nested throughout our entire lives. Right. So I'll give you an example of that. So homophily is everywhere. So we have blue states and red states, right? So people, tend to group together in various parts of the country, like-minded. But even within a red state like Texas, we have this urban versus rural divide, where a lot of people who are in the rural tend to be conservatives. A lot of people who are liberal tend to be urban, right? So even within a red state, you have this homophily effect. Even within a city like Detroit, right, which is an urban city, which is heavily Democrat, even there you have this homophily, or at least this grouping together by something like race. And so in essence, if you gave me your address in Detroit, I would have a pretty good way of determining what race you were. And then if I had other pieces of information about you in addition to your address, I could probably make a good estimation of your actual race. And it's not just there, it's universities. Some universities have more or less population distribution, but even within universities, right? If you look at the field of library science, most of the people in library science are white females, where in computer science, it tends to be white and Asian males. So even within a university, we tend to, coalesce, I guess you can say, homophily seems to show up. It's not that homophily is always bad, always good, or even by choice. It may not always be by choice, but we live in a society where homophily is everywhere, right? I mean, if you grow up in a particular side town as a particular member of a group, you have a shared experiences, right? And so this homophily, it's all through society. For the last 100 years, an unlimited number of studies have shown just how powerful this actually is. And turns out like people not only like each other, they also tend to like the same things, right? So like, you tend to like the same things your friends like, right? And so this is actually pretty good for these social networking companies like Facebook or Google or Instagram or Twitter, right? They basically, if you're Facebook, you make your money because you can learn something about person A from their friends and vice versa. And then so if person A buys a pair of shoes, chances are that person's friend is going to like that shoe too, right? So homophily really helps this. That's how you get this whole big network, right? So a lot of what's driving these AI enabled platforms is homophily. It's often the magic behind a lot of economic success when it comes to these AI enabled environments and platforms, right? Especially social networking sites. So it's not always necessarily bad, but it's there. It's there, and it's a very powerful factor. Now, so what does that mean if we go back to our model about how AI actually works? Well, it means that basically one problematic is that the data that these AI systems are relying on are filled with homophily. And some of that's more problematic than others. Some of it is more obvious. So some of it is not very obvious. And I'll give you an example of what I mean by that. So let's suppose here I have an organization, they have this data, and they have employees for the last 10 years. They have data, they have age, gender, education, then they have the employee performance. And they say, we want to develop a model and see if we can predict our employees' performance. And so they run the model, create this model, and say, here we go, voila. It turns out we can use age, gender, educational level, the university ranking of the school you've graduated from, all these other variables, and we can predict your performance in our organization. So we say, okay, look, we know the things that are related to good employee performance, right? We have this data, we have this model, we can predict how well someone's going to do in our organization. So we say, so how about this? How about we take this model, all right, and we're going to apply it to the people that we're going to hire. So if someone wants to get if someone applies to our company, we're going to take their data, their age, their gender, their educational level, university rankings, right, blah, blah, and we're going to predict their performance score. And if that score is 8 or out of 10 or above, we're going to hire that person because according to our data, that person should do well in our organization. It's a reasonable approach, right? You would say, and if that person scores lower, less than 8, we won't hire that person. So you think, hey, man, this is a great way to use this data, right? We can actually predict how well someone's going to perform before we hire them, and we can determine, if we should hire them or not, right? It's a pretty idea. And then you see a lot of stories about, age becoming important, gender, university ranking, blah, blah, blah. And so let's talk about how that works in ways that we don't really think about it. So first of all, this leads to a problem. I tell my students, I call it correlation is not causation, right? So the correlation is X is related to Y, which is different than causation, which is Y is the driver of X, right? So I'm gonna give an example. Let's suppose we discover in our previous iteration here that gender was actually a strong predictor of performance, right? We say, well, it turns out that gender does matter here, right? Well, even if we found a significant relationship, it wouldn't mean that gender predicts or leads to performance. It would mean that they are related, right? And even then, we wouldn't know why they're related, but they're related. And let's talk about how they could be related, right? You could say, well, men perform better than women. Not so fast. So let's look at this. So first of all, employee performance is a performance rating, right? So we tend to think of employee performance as an object number. It actually isn't, right? It's actually a score that you're getting, all right? So it's a very social construct. And so in many organizations, your employee performance rating is based upon your rating by your supervisor and your actual peers, right? They actually, they give you some rating, 360-degree rating, whatever they call it, and that's what determines. According to all of the literature in the last 25 years, one of the strongest factor in determining your supervisor and peer rating is how similar you are to your supervisor and your peers. So if you're in an organization and it's, 70% men and, maybe 90% of supervisors are men, if you're a man, you're going to get a higher rating than a woman, right? Typically, all literature says that supervisors and peers rate people who are like them higher than people who are not like them, right? So here's what happened in our analysis. So it turns out, we found that gender is related to employee performance rating, but it's really related because similarity in peers and supervisor is what determines how well you actually your actual score in the rating, right? And so if most of the peers are men and most of the supervisors are men, if you're a woman, you're going to appear to perform worse, right? Gender is going to seem like an important factor in performance, when actually it's not gender that's driving it, it's similarity to the current environment. The problem is that these two variables are hidden. So they're not in the data set. Like there's no supervisor similarity variable in the data set, right? So these are hidden variables. And so what happens is that you run the analysis, gender comes up to be significant. And you say, oh, well, men perform better than women. Maybe that's what, no, that's not what happened. What happened is that, men are, the majority in the company, they are the majority of supervisors. And we know that people rate people like them higher. So they are rating other men higher than other women, which is different than actual performance, right? But you don't have those variables in there. And so when the relationship comes up significant, you think gender really matters. And so that, in essence, what will happen is when you go to evaluate a female candidate using this criteria, you will be less likely to hire that candidate because that person's a female. You can do the same thing with age and university ranking, right? So, I love the University of Michigan, but if you're a supervisor, graduated from the University of Michigan, and you went to the University of Michigan, odds are that person is going to give you a higher evaluation, right? You have something in common. And so basically, it looks like university rankings really matter. But what really matters is how similar you are to the person, to people around you and the people evaluating you, right? And so what you end up doing is that you don't end up predicting. So I'll take this a little further here. So with this actual model, you're not predicting how well someone's going to perform. You're predicting how similar they are to your existing organization, right? So the actual model is like, how similar is this applicant to our current supervisor? How similar is this applicant to our current workforce, right? And so you get this self-fulfilling system, right? You're basically hiring more people who are like the people you already have. And you think that, you think that it makes sense, right? I'm not biased. I'm just using the data. But the bias is within the data, right? It's not so easily removable. And it's not so easily obvious where the bias is. You would, if you were looking, you would say, hey, I'm predicting performance. This is an object measure. That's what, that's fairness, right? How much, how else can you be fair? And even if you take out age and gender from the data set, other things are going to be related to age and gender. So I'll give you an example. One company tried to avoid bias against female applicants. So they took gender out of the actual data set and thought they were fine. They discovered later that the actual AI was biased against people who went to majority female institutions, right? Voila. So even there, it still pops up. So you can pull out these variables like gender and age, but because of homophily, they're so intertwined with our experiences, with our choices of life, that they reappear in different forms in the data set. And we don't, if we don't know what the data is doing, we don't know what the AI is doing. All we know is, hey, this can predict something, and that's good enough. And these are the kind of bias that's hard to understand, hard to communicate that to people in the organization because they don't necessarily see it. Now let's go a little bit further here. So the biases. The problem is that it's not that there's biased data, but instead data are biased, right? So basically, the actual, if the actual data is from society, society is biased, right? We are biased people. We live a life. I mean, so if the AI is pulling information from the real world, well, the actual bias, the racist, and all this homophobia, all that stuff is in the data set, right? And so if the AI is developing itself of using that data to develop an actual model to make predictions, the bias is already in there. And in some ways we can detect it. In some ways we just don't know it's there. Like we just bypass it, right? And we could go out of a way to take it out as much as possible, but it's not quite clear that we can, for a number of reasons. One, it's not clear that we know where it is everywhere, right? I mean, basically, it's within a society. If you have an organization and you spend the last 25 years being biased against minorities, like the AI is going to be reflective of that. Right? It's going to be all up in the data set. You can't easily say, I'm going to remove out the actual bias. It's almost, I wouldn't say impossible, but it's more about, after it makes a bias decision, are you going to stop, and fix it before you actually follow through? Yeah, that would be a much better approach. But basically, to what degree these AI systems reflect society and is drawing data from society, and society is biased, these AI systems are going to be biased. There's no way to avoid that. Now, here's the other question I want to bring up. To go back to my example here, right? When my airport example. So if Uber was matching me with African-American drivers because they wanted to, because I'm African-American, should we change that? And so we could say, yeah, of course, we don't want a society where people are, just, sort of biased or matching people. At the same time, if I have a better experience with an African-American driver and I give this person a higher tip, are we better off, having an Uber assign him, let's say, a white passenger where he may not get a higher rating or a tip, right? And so, it's, this idea of bias, a lot of the bias is built into these models. And it's a lot of the ability of these AI systems to predict is based on bias. I mean, bias is the magic that's driving these systems. And it's not always clear that we're removing that bias. I mean, who are you helping? You can say, well, we take out the bias out of this scenario, we're helping society, but we may not be helping that particular driver, right? So, I mean, some of the things that I've actually thought about doing, so we actually published an article recently on removing some of the bias from organizations. And some of the things I talk about is maybe what you should think about doing is giving your employees more options to understand what's going on. So the design systems that are more transparent, that are better at explaining how they reach the decision, that can visualize what's happening here, and give the employees an actual voice to intervene, to say, no, we're not going to do this. The AI recommends hiring these people, but wait a minute, I think it's wrong, right? And so I'm going to make some changes. And so another thing is, designing AI systems that are interpretable, people can understand what's going on, and giving the users the ability to actually intervene. Some of the questions you got to think about are issues of actual privacy. You're getting this data, some of this data. If you want to remove the bias, it probably requires you getting a lot of information about the individual that will, have some issues of privacy. It's hard to detect discrimination based upon gender and race without knowing the gender or race of the individuals, right? And how much autonomy should we give this? How things are going to change based upon the context. Fair to whom? Who we're going to be fair to? Is the customer or the employee? There's other issues of quality versus AI accountability. So there's a lot of questions that we have to actually think about going forward and address these issues. It's not clear to me that removing a bias is going to be as easy as we think it is. It is. I can see why that's so easy to blame these companies, because in many ways they benefit from some of this bias. This is not like by accident. On the other hand, to pretend that they could easily remove all the biases, I don't think so, because it's easy to offload the responsibility to the to the tech company and the AI app, it's hard to look at ourselves as a society and say, yeah, maybe the AI is biased, but it's biased because we make biased decisions. And so how are we going to fix, society? And so to some extent, I think a lot of this biased discussion is important, but I think it shifts the responsibility away from the fact that we are a very biased society.